Hi, welcome back everyone. For this video we are going to be taking a look at the second part of the 8.7 notes. In the first part of the notes we learned a couple formulas that we need to know along with some terminology that we need to know regarding circles. So just to quickly refresh our memory, we have a circle here with a center at C. This distance from the center out to the circle, that is called the radius of the circle. And if I go from one side of the circle through the center to the other side of the circle, so this segment right here, that is called the diameter of the circle. And we talked about how the circumference of a circle is the distance all the way around it. It's almost like the perimeter of a circle, right? And we learned that if we take the circumference divided by the diameter, we get that special number called pi, which is oftentimes rounded out to 3.14. We understand that it actually goes on infinitely. The numbers after the decimal point go on infinitely after that, but we can round it to 3.14 in a lot of cases. From this relationship, we get two formulas for the circumference of a circle. If you want to know what the circumference is, if you want to know the distance around a circle, you can either take pi times the diameter, or you can take 2 times pi times the radius, since 2 times the radius is the same as the diameter. If you want to know the area of a circle, you take pi times the radius squared, and remember that radius squared means radius times itself. So that's just a quick review over what we talked about in part 1 of the video, or part 1 of the 8.7 notes rather. Now let's take a look at the new part of the notes that we're going to learn about today. First, a couple definitions that we have to clarify that we're going to be using when we get down into here. An angle whose center is, I'm sorry, I misspoke there. An angle whose vertex is at the center of a circle, that's going to be called a central angle of the circle. So you can see down here I have an example of a central angle. Angle ABC is an angle with a vertex at B, which is the center of this circle. So that is an example of a central angle. The region of a circle that's determined by two radii, remember radii is the plural form of radius, the region of a circle determined by two radii and a part of the circle is called a sector of the circle. It's kind of like basically if you think of a circle like a piece of pie, or I'm sorry, if you think of the circle like the whole pie or a whole pizza, a sector of the circle is kind of like a slice of that pizza or a slice of that pie. You can see the shaded region right here is what we're talking about when we talk about a sector of a circle. This shaded region is formed by the radius BC and the radius AB and this part of the circle right here. Those three things together kind of enclose the shaded region, and that's called a sector of the circle. And what we're going to be working on is how we can find the area of a sector of a circle. And if we want to find the area of a sector of a circle, we need to know two things. We need to know the radius of the circle, and we need to know the measure of that central angle that's creating that sector, right? And the formula that we're going to use, it looks a little bit different than most other formulas we've talked about so far in Chapter 8. It doesn't start with A equals like we're kind of used to the area formula starting with. We're used to formulas that say A equals and then it's got some stuff on this side of the formula. Instead, this one's going to be set up like a proportion. Now we know that a proportion is where we have one fraction set equal to another fraction. So the proportion we're going to use if we're going to find the area of a sector is on the one side we're going to take the area of the sector over the area of the entire circle. So we know that if we're using this proportion to find the area of a sector, we're not going to know this right off the bat. So you're probably going to maybe put an A there or an X to kind of indicate that you don't know this. To find the area of the entire circle, that's why we need to know the radius, because we're going to do pi r squared right there. And that's going to set equal to the other side of the proportion, which is going to be the measure of the central angle that creates that sector. So in this case, it would be this measure of angle ABC. If I want to know the area of the shaded region, I would need to know the radius, so I could do this bottom part of this side, and I'm going to use the central angle measurement on the top of this other one, and on the bottom is going to be 360. It's always going to be 360. So that formula looks a little bit different. Sometimes you might want to shorten it to x over pi r squared equals central angle over 360. Might be a little bit of an easier way to remember that. And then, of course, when we actually use this, we're going to be cross multiplying. We're going to take this number times this number and the x times the 360, and that'll set up an equation that we should be able to solve. So let's do a quick example here. In the circle above, if the measure of angle ABC was 120 degrees, and if the radius was 10 centimeters, what would be the area of this shaded sector? So you can see I'm going to start by writing out my x over pi r squared equals central angle over 360. And then from that, I'm going to fill in the parts that I can. I obviously can't fill in the x because that's what I'm trying to find, so I'll leave that as an x. I know my radius is 10, so I'll write pi times 10 squared equals, I know my central angle is 120, so that goes on top, and then I have 360 on the bottom of my second fraction. Now at this point I might want to go ahead and write this, instead of using the exponent there, I might want to write it in terms of pi. So pi times 10 squared could be written as 100 pi, because 10 squared is 100, so I can write that as 100 times pi, or 100 pi. So now I'm going to do the cross multiplication. I'm going to take the 120 and multiply it by 100. So I have or times 100 pi, I should say. So I have 120 times 100 pi, and that's going to equal the x times the 360, which I'll just write as 360x. Now I might want to grab my calculator and do 120 times 100 pi, or I can remember that 100 pi is going to be 100 times 3.14, so it'll come out to be about 314. Maybe I can do that just in my head, since 100 is usually a pretty easy number to multiply by. In any case, I'm going to take 120 times 100 pi, and that's going to give me about 3,700, or 37, let me say that again, that's going to give me about 37,000, and I'll round this, I'll say 37,699 is what this is going to give me, and that equals 360 times x. Now to get my x by itself, I'm going to divide both sides by 360. And if I divide my last answer by 360 on my calculator, I get about, I'll round to the nearest whole number here. It's going to give me about 105 square centimeters for the area of my sector. All right, 105 square centimeters is the area of this shaded in portion right here. So now what I'd like you to do is, the video is going to pause here in a second, and it's going to ask you for the answers to questions 9, 10, and 11. So I want you to go ahead and do that. Once you answer those questions, that's about all we have for this video. So good luck, and I'll see you in the next video.